Hello everyone, welcome back to my channel. Today let's go over a premium hard question in the Panda section that I just solved on my own. So I'm really happy about this because I was able to come up with my own solution without any assistance, which is rare for a hard problem. But this one is basically similar to the two-pointer trapping rainwater question. So if you solve that one, this one isn't too hard. It's basically the same thing, except the array is tilted and you have to reorder it. So let's go ahead and do that. And we want to return a data frame. So let's go ahead and do that. This is the skeleton pd.dataframe heights columns equals to total trapped water, and then dot head 1, and that's going to give us the, because it's only one integer, right? So that's null. So let's go ahead and populate that with a dummy value. Heights total trapped water is equal to 0. And now we have to basically get this column and flip it around so it's right. And so basically rotate it like this. So let me show you how to do that. Let's call this current for IV and enumerate heights of height cur.append v. So just literally going from top to bottom to have the array. Cool. So now we can just apply two pointers on this because this diagram is confusing. And what they're asking you to do is really trying to measure the difference between the current left. So we have to take the whichever one is bigger from the left and the right side. So we're coming inwards from the left and the right side. And then we have to basically take the difference between the current and the next one. So the current and the next one is going to be inside. This is going to be inside, depending on which one's bigger. So basically here, the only one that's going to be bigger is this. So we don't take anything and we move the right pointer. At this point, this one's still bigger. So we calculate the difference. That's 1 unit this way. And then at this point, they are equal. So you can take either one. You move this one in and then they're equal again. So the difference between this and this is 1. So you can take 1 here, you move this pointer in, and you just keep moving the pointers in until you basically can't move them in, because at the last unit you can't trap any water. So I know this is a little confusing, but hopefully when I code it up it's a little easier to understand. So we're going to start at 0, length of cur minus 1, while left is less than right, and we're going to take the max left, and the max right is going to be the current of left, right, the two heights starting at both ends, current of right. And now we have to ask if max left is less than max right. If they're equal, then it doesn't matter. You can use either one, right? So if this is less, then we have to move the left pointer in, because we're trying to see how much water we can trap. We're trying to eliminate that constraint by moving the one that's lesser, right? It's kind of like that same with a number of containers, the container with the most water question. It's the same idea. So in this case, we would say max left is max of, remember, the previous and the current. So max left and height or current of left, because this is the one that was moved. So whatever one is bigger is going to be added. So for example, this and this one, this is still bigger. So even though the left pointer is here, it's still going to be 1. So in that case, we're going to add max left, max right, same thing, inwards. Whichever one is the bigger one, then we're just going to keep it as the bigger one, because we want to add, because the bigger one is how much water we can trap. So max of max right, current of right. And then at the end, if we print answer, you can see that we don't want to end up here. Answer plus equals to max right, answer 0. Okay, so that's not correct. Again, I think I messed this up. I think we want the difference between height of left, so max left, minus, because this is already moved, right? Current of left, max right, minus current of right. So the difference between whatever we're coming inwards, so it doesn't matter, we keep the biggest one, because this, if this is bigger than this one, then there is going to be water we can trap, because this is a difference of 1. This is 0, this is 1, so that's the difference. Here, for example, this is, we can't, well, we can trap water because this is, well, we're going to do that with the left pointer, I think. So this picture gets a little confusing because we end the left pointer here and we end the right pointer here. You can't trap anything at the very top. So then we go here, and again, we get the difference. You can't trap anything. We're comparing the heights on both sides and coming inwards. So I know it's a little confusing, but hopefully that made a little bit of sense. And then at the end, we can say heights of total trapped water is equal to answer, and then we just return the first one, right? So let's run this, submit it, and there you go. Passes all test cases, and 100% for both runtime and memory, which I've never gotten that for a question that I've solved on my own without any assistance, so I'm really happy about that. And again, you know, that's it for this video, and hopefully this wasn't too bad. If it doesn't make sense, you can go ahead and review trapping rainwater or containers with the most water. It'll give you this 2-pointer idea. And yep, that's it for this video. Thank you for watching, and stay tuned for more.